To have a larger fuse, in other words a 20 amp fuse on a piece of 20 gauge wire. By the way, gauges, the lower the number, the thicker the wire. This is probably 16 or 18 gauge wire, known as bell wire. The wire on your starter is 6 or 8 gauge. Welding wire is down in the 0 and then gets even below that. So depending on what it is, if you're going to install a starter in your car, you don't want to run a 10 gauge or a 12 gauge wire to it. It's just not going to last. The way to power a high amperage circuit with small, or to control a high amperage circuit with small wire, is to use relays. And I don't want to get too far into that, but let me get back on track. We've talked about resistance. The body on the car is going to rust over time. I don't know how well this demonstration is going to work with this 2-battery flashlight. I wish I had a 1. But the further I go down this wire from my clamp, can you see a difference? Okay. The further I get away on the body of the car, the lower that bulb is going to get. And the reason is because some of it's being dissipated. The resistance is bleeding off the voltage, if you will. The voltage is getting lower. If I were to put a good accurate meter on here, we'd probably start down at this end with 3 volts and we're ending up with probably less than 2 down here. Steel is not a good conductor. So they don't make wire out of steel, they make it out of copper. Copper's a really good conductor. Gold is a great conductor. The reason that they go with the gold terminals on the end of speaker wires is when you make a connection, okay, over time that connection can move and corrode and degrade. By the way, any loose connections rubbing around, you'll see that bulb bouncing on and off. In a motor situation, any type of high current situation, that bouncing on and off is going to cause spikes. In other words, a motor draws a little bit more to start and then settles in and starts running. Well, if you keep a fan on your car starting and stopping like that, what's going to happen is you're going to get heat at the point where the wire is attached. Over time, that heat's going to build up and it's going to do something. It may melt the electrical connector. It may blow the fuse. Matt?
I understand about having the right wire for
No. Nope. None whatsoever other than space. Yeah, overkill, exactly. The service cables that feed your house, are overkill, I guarantee. They're also made out of aluminum because copper's too expensive. But they give you more than you need because it's going to last a lot longer. Okay? Aluminum, copper, they don't break down long enough for that to have been the worry, but you can't use too much. You can use too little, and that has consequences. But it's usually a cost thing. I mean, 1 gauge welding wire is $6, $7 a foot, whereas 6 gauge battery cable is $1 a foot. So that would be the only reason you wouldn't go over was cost. I won't get into it with you here. I can post places to go on the website to show you the formula to figure out, hey, I got a 150 watt light on my roof. Actually 2 of them. Okay, they run on 12 volts. They each draw 8 amps. What size wire do I need? And I'm going to put a lot of the stuff we talk about here because I've got really good visual stuff that just couldn't print on paper. So I didn't bring handouts with me this time like I did with the heater because I'll follow up on the website with this stuff. All right, simple continuity tester. I took the circuit and shut it down. But what if you just want to simply test something that's already on the car and the circuit's going to be energized? Then what you want to do is connect the battery back up. yourself a test light. These are simple test lights. I've actually modified this one. I'll show you what I did. Well, you know what? We'll talk about it. Test light, again, it's an even simpler circuit than this one. It's just a light and a piece of wire with a sharp spike on the end of it. Now these tend to be really, really sharp. And there's a reason for that. It's because you want to be able to poke through the jacket of a wire. Oh, speaking of heavy gauge wire and light gauge wire, don't look at the thickness of a wire and determine that, hey, that's a really heavy wire. Because if you go to Harbor Freight and buy jumper cables that are this big around, I guarantee you that the jackets on them are going to be that thick. And that's a common trick. You buy jumper cables that you think are really heavy, and turn this off because we're blinding ourselves. See if I can turn it down a little bit. Notice when I drop the voltage that the flashing goes slower. Jumper cables. Go out, you buy yourself a nice set of $8 Harbor Freight jumper cables. You pull the cars next to each other and you hook them up. You let the car run for just a minute, you turn the key, and you get absolutely nothing, or maybe a little bit of ticking. So then somebody sits behind the car that's running and you go 10 minutes. What you're doing is you're allowing the battery on the other side to charge off of this one, but you haven't given it enough of a conductor in it for a decent amount of current to flow through. I learned this lesson long before I learned about this stuff. There was a guy that used to work for the railroad. He made himself a set of 35-foot-long jumper cables out of weld lead. Okay, and the reason he did that is because when you pull up behind somebody on a highway, you got to jump them. You got to go and make a U-turn in the middle of an interstate, which is absolutely insane. So he wanted to be able to jump the car from behind it. With those cables, he could pull up to your car, put his battery to your battery, and your car would go and start up like you just put his battery in the car. It's because it can carry every bit of current that you can give it through that wire. So when you buy yourself a set of jumper cables, spend the extra money, but look at the wire gauge. Make sure that it's a 6-gauge or a 4-gauge or a 2-gauge wire. Or, better yet, go to the welding supply or to a swap meet and buy a welding lead. Okay? Then go to Harbor Freight, because the handles are made out of copper no matter which way you look at it. And get yourself a set of copper handles and build yourself a set of jumper cables. Another trick, and you guys will know, some of the younger guys won't know, Frank will probably know, in the old days when the bumpers were chrome, all you do is you take and you put two cars together, and now you've completed the negative circuit. Then you took your tire iron and you went from the positive to the positive, and the guy started his car. By the way, if you did that with a coat hanger, you went to the hospital because you got second-degree burns because that wire turned into it.
Sounds like hilarious.
That's right. I watched my brother do it with a tire iron, and I didn't have one. All right, so here we go. We've got the test light here. I'm going to hook it up to the negative side of the circuit here, and I'm going to put it here. I got a green light, but it's not blinking. So I'm before the flasher in the circuit. Now what I did here, you guys in the back, all these wires they're not the same color, but there's not any one of them that indicates what's going on here. And I did that because a lot of times you're working up under a dashboard, you couldn't tell what color the wire was anyway. But we know we're looking for the flasher circuit. I've got the light on that's flashing. All I've got to do is grab hold of the harness here, separate the wires, and just start poking. Eventually, I hit it on the first one and all the wires are black. Eventually, that light's going to start flashing, which is what it's doing. Alright, now, I want to show you something cool about my test light.
Get hypnotized here with that light.
Okay. Alright. This test light is a non-standard test light, and the reason I say that is because somebody taught me a trick with LEDs a while back, and I'll post this on the website. I'll let you guys pass that one around. That's a little Radio Shack, what's called a dual color LED. I take my regular light out of my test light, I put a 330 ohm resistor on it. Again, we talked about resistors. You can take LEDs. LEDs are dirt cheap. You can get some really, really bright